Okay, so the final part for the thermodynamics is the free energy change, also known as Gibbs free energy. So free energy, which is denoted delta G, is a measure of predicting whether a reaction is feasible. It takes into account enthalpy, entropy, and temperature, and it has the formula delta G equals delta H minus T times delta S. The units are joules per mole. So because enthalpy's units are kilojoules per mole, we have to times the enthalpy by 1000 to get all the units correct. A reaction is feasible only when delta G is equal to or less than 0, so negative basically. A feasible reaction may occur, but it may not, and this is because its activation energy may be too high or the reaction may be too slow. So temperature's effect on free energy. When enthalpy and entropy both have the same sign, so both are positive or both are negative, delta G will be feasible at some temperatures but not feasible in others. When both of the values are positive, then the free energy will favour high temperatures. When both are negative, they'll favour low temperatures. If delta H, so enthalpy, is positive, and entropy is negative, then the reaction will never be feasible regardless of the temperature, because the delta G value will always be positive, which we know cannot be feasible. When enthalpy is negative and entropy is positive, however, the reaction will always be feasible regardless of the temperature, because the value will always be negative. You may be asked to find the temperature where the reaction just becomes feasible. We need to realise that that is when delta G equals 0, because if it was 0.1, it would not be feasible. So what we do is we let delta G equal 0, we then rearrange the free energy equation to make T the subject, and what we get is T equals delta H over delta S.